Hello students, good morning, good evening and good night depending on which time we are going to observe this lecture. Welcome to the fourth lecture on aldehyde, ketone and carboxylic acid chapter. So far we have discussed three topics in this chapter. First lecture we have discussed about the nomenclature, and it was basically the introduction to this chapter. What is carboxylic acid, what is aldehyde, what is ketone, the basic thing we have discussed in that lecture, and also discussed about the nomenclature of the three two compounds that we have discussed. Carboxylic acid we will discuss separately. In the second lecture we have discussed about the preparation of aldehyde and ketones. How do we prepare in different ways, different methods that we have discussed. And in the third lecture we have discussed about the very important chemical reactions, that is the nucleophilic additions reactions as being undergo by the aldehyde and ketones, and also we have discussed the physical properties, some of the important physical properties. And that is this lecture we will be discussed on another two very important chemical properties, that is the oxidation and reduction as being undergone by the aldehyde and ketones. So heading of today's lecture is we will discuss the very important two chemical reactions that has been undergo by the aldehyde and ketones, that is the oxidation and anhydrous reduction. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, let us understand the oxidation of the aldehyde and ketones. So we can write the oxidation. First we will discuss about the aldehydes. Aldehyde, we can, if we see the structure of the aldehyde, we find, what we find, that there is one hydrogen atom attached to the carbon atom of the carbonyl group, and that is why aldehyde can be easily being oxidized to carboxylic acid by the mild oxidizing agent like mild oxidizing agent like bromine. Second, that is Tollens reagents. Third, filling solution. And fourth, that is Benedict solution. So aldehyde can be easily oxidized to carboxylic acid by all these mild oxidizing agent. That means aldehyde can reduce all these mild reagents, that is all these things, that bromine, Tollens reagents, filling solutions and Benedict solutions. Let us understand what this thing that will be the new to you. Let us understand what is basically in terms of chemical properties in chemical compositions. What is all those things? Bromine, that we know, that is no need to discuss anything. Then first we will discuss the Tollens reagents. Tollens reagents, Tollens reagent. Tollens reagent is nothing but the ammoniacal silver nitrate solutions. So we can write it is ammoniacal silver nitrate solution. Silver nitrate solution. Aldehyde reduce this Tollens reagent into the silver metal that has been deposited as a shining silver mirror. That is a very important and interesting experiment that you can see, that when we warm this aldehyde with this Tollens reagent, you will find there is a shining silver mirror appearance, and from that you can able to say that the solution is a aldehyde. That is a very important test. The reaction in this, let us understand. Reaction is basically, suppose this is RCHO aldehyde, then ammoniacal silver nitrate solution, we will take the ions. That is basically a complex compound. This complex compound, you can see, that is AgNO3 whole 2, and it will have a charge, that is a plus or charge, and the reaction is carried out in the alkaline solution. So this will be the reactant, and product, naturally the aldehyde is oxidized to the carboxylic acid. So this is carboxylic ion, and plus you will find silver is deposited as a silver metal. This is a silver metal, and ammonia is produced, and this, and W2, and this will be now it is a balance. So you can see there is a silver has been reduced by this aldehyde to the silver nitrate solution, reduced to the silver. So we will find there is a shining silver mirror appearance in the reaction bath after the reaction. Second, we are going to discuss, that is the Fehling solution. Fehling solution. Fehling solution is basically composed of the two solutions, solution A and solution B, suppose, and both the solution, when it is, we are tell it is a Fehling solution, means it is been mixes with each other with 50-50%. And solution A, suppose solution A is the alkaline, solution A is alkaline copper sulfate, CuSO4, and solution B is Rossili salt. Rossili salt. This is Rossili salt. It is the basically sodium, potassium. It is sodium, potassium tartarate. Sodium, potassium tartarate. This is when we mix 50% of this and 50% of this, we mix, and this is when it is boiled, when it is heated, not boiled, it is just heated. what you find, there is a very characteristic things. That is, there is a precipitation of Cu2O. There is a red brown precipitation of Cu2O we will observe. And the reaction for this CHO, we are taking the ions plus OH minus and again carboxylate ion plus there is a precipitation of Cu2O. This is the red brown precipitation we will found, red brown, where here silver mirror, shining silver mirror. It is a red brown and there is H2O. So we balance it. Okay, now it is a balance. So what we find, there is a red brown precipitation when we heat the filling solution with the aldehyde. And another, that is a Benedict solution. Benedict solution is nothing but that is the alkaline copper sulfate with the sodium citrate, and this will have the same reaction as it is this. Now there are two types of aldehydes, you know, that is aromatic aldehyde and aliphatic aldehydes. Tolerance reagent, this will be reduced by both the aliphatic, we can write this aliphatic aldehyde plus aromatic aldehyde. Both will reduce the tolerance reagent. But here in case of filling, it is only the aliphatic, only the open chain, that is the aliphatic aldehyde. Aliphatic aldehydes, not aromatic. So in exam, this type of question might ask about this, right? So we understand the oxidation of the aldehyde. Aldehyde can be easily oxidized by the mild oxidizing agent like tolerance reagent, filling solution and Benedict solutions. Now what about the oxidation of the ketone? Oxidation of ketone. Ketone cannot be oxidized by a mild oxidizing agent like your tolerance reagents, filling salts or Benedict solutions. It cannot be. Requires very vigorous conditions. That is, we require a very strong oxidizing agent. Strong oxidizing agent like acidic K2Cr2O7, right, or alkaline KNMnO4. So this very strong oxidizing agent is required for oxidation of the ketones, and in this case you will find there is the rupture of the carbon bond on either side of the keto group, and it will going to result the carboxylic acid with having the lesser carbon atom than the parent ketones. So let us understand which type of breakages is occurred while now here breaking of the bonds can happen. Suppose it is a 1 number carbon, 2 and 3. When there is a breaking in this 1 and 2 position at that time, which type of carboxylic acid will produce? Let us understand. It will be, suppose this is R and this is R1. The alkyl group is different. So at that time, RCOOH, when this bond is breaking, and it will also produce R dash CH2COOH. And another thing, in this case is C1 and C2 bond has been break. The cleavage of the bond C1 and carbon number 1 and carbon number 2. And another case, when there is a breaking of the carbon number 2 and carbon number 3, at that time, which type of product will be produced? Carboxylic acid. You can see this is RCH2COOH plus R dash COOH. So every time what you find, the carboxylic acid which is produced from the oxidation of this ketone, you will find that there is a lesser carboxylic acid which having the lesser number of carbon atom. You can see here both the carboxylic acid produced from this oxidation, that is, you will find this. And there is a rule also that we must understand. This is the Popov rules. Popov rules is says when for the unsymmetric ketone, unsymmetric ketone means when this R and R dash is will be different. One will be bigger alkyl group and another is the smaller alkyl group. So at that time, for unsymmetric ketones, the rules is this: the keto group will always stays with the smaller alkyl group. So we can write keto group with smaller alkyl group, Okay, right? So this is the oxidation of the ketones. Now we are going to discuss another very important thing regarding this oxidation process, that is the haloform reactions. Oxidation of the methyl ketone through haloform reaction, that we are going to discuss now. We are going to discuss the oxidation of methyl ketone. Oxidation of methyl ketones. That is the haloform reaction. Haloform reaction. That is a very important reaction that we are going to discuss. Basically, when the aldehyde and ketone having this CH3CO group in the excess halogen in presence of the alkali, it will going to produce two very important products. Number one, the methyl group has been transformed into the haloform, and there is a formation of the salts of, in case of sodium NaOH, the sodium salts of carboxylic acid, which is having the one carbon atom less than the aldehydes or ketones. So let us understand the reaction. So we understand it. This is a methyl ketone and this is reacted in presence of excess. There is a excess halogen in presence of the alkali, and it will going to create the sodium hypohalite. Suppose this is NaOX.
right? So what is going to produce here, this methyl has been transformed into the halo form. Halo form is CH(X3), and it will produce another, that is the sodium salt of this carboxylic acid, that RCOONA. And here you can see this carboxylic acid have the lesser carbon atom than this parent aldehyde or ketones, and this is called the halo form reaction. And here X is basically the halogen, that is chlorine, bromine or iodine. So this is sodium hypohalite, and it is reacted with this methyl ketone, and this reaction only be possible when there is the CH3CO group, and this reaction will help us to identify the CH3CO group in any compound, or it will have CH3CHOH group in the compound, and it is basically being oxidized to this CH3CO. So this group can be easily understand from this haloform reaction. If we use the iodine at that time, it will going to produce the yellow precipitation of the haloforms, that is iodoform. That is, you will get a iodoform, and this iodoform will be a very yellow precipitation, and from this we will able to understand about the CH3CO group. So we understand the haloform reaction. It is basically in excess halogen in presence of alkali. Here, that is, we are taking sodium hypohalite. When it is chlorine, this is sodium hypochlorite, sodium hypohalite, sodium hypobromide. In this way, we will identify this reagent. So this is another oxidation reaction of the aldehyde and ketone. Okay. Now we are going to discuss the second part of this lecture, that is a reduction. Reduction is very important because when there is oxidation, naturally there will be the reduction. So how this reduction will be there, reaction will be there. It is a very important and simple rule. The aldehyde, suppose this is a aldehyde. When aldehyde is reduced, it will going to produce the alcohol. This alcohol is the first degree alcohol. We will call it is a primary alcohol, first degree alcohol. When aldehyde reduced, when ketone reduced, CO, ketone. When this ketone reduced, it will going to produce the secondary alcohol. Secondary alcohol by 2 degree alcohol. Now, what will be the reducing agent? That is very important to understand. You should know. There are several reducing agent. Number one, that is the catalytic reducing agent. Catalytic reducing agent. Catalytic reducing agent, it is basically the hydrogen when passed over a finely divided nickel or platinum or palladium. That is, we can write hydrogen in presence of catalyst. That is platinum, that is nickel, and that is palladium. Second reducing agent is NaBH4. NaBH4 is nothing but the sodium borohydride, and this is a very mild, this is a very good reducing agent, and it will easily convert this carbonyl carbon atom into the aldehyde, into the alcohol. Third reducing agent, that is very important, the versatile lithium aluminum hydride. This not only reduce this carbonyl carbon atom to the aldehyde, but it can reduce other
materials also, other compounds. That is, it can reduce acid, it can reduce nitrile group, it can reduce amide group, it can. Second, aldehyde not only reduce the alcohol. If there is a reagent, that is the proper reagent we use, as for example, that we are now going to discuss a very important reaction, that is the Clemenson reduction. Clemenson reduction. This Clemenson reduction, in this case, the aldehyde or ketone has been reduced in presence of, this is reaction is this. This is carbonyl group, and in presence of zinc amalgam and concentrated HCl, and it will be produced, it will be reduced to hydrocarbon. So alkane can easily be prepared from the aldehyde or ketone with these Clemenson reductions. Another important reaction, that is Wolff-Kastner reduction. Wolff-Kastner reduction. In this case, first the aldehyde or ketone, that is a carbonyl group, has been reacted with the hydrogen. Reacted with hydrogen. This is hydrogen. So it will going to produce this, right? And after that what have to do? Now you have to boil with KOH with high boiling solution, that is the ethylene glycol. Ethylene glycol. So it is going to produce this. Okay. So that is all for today's lecture. This is the fourth lecture. In this lecture that we have discussed about this very important thing, that is the oxidation and reduction reaction of the aldehyde and ketones. And in the previous 3 lectures also discussed. The first lecture we have discussed about the nomenclature. Second lecture we have discussed about the preparations. And the third lecture we have discussed about the nucleophilic addition reactions of the aldehyde and ketones. That is all. I hope that all the points are clear to you. If you have any problem, you can comment in the comment sections. Thank you very much for watching, and I will say one thing, this is a basically service to those students who could not afford these costly tuitions, and I think they will be helpful from this to achieve their targets. Thank you very much for watching, and meet you in the next lecture. Thank you.